Great. Good morning, everyone. It's a great honor to be here in OpenFabrics Alliance Workshop. My name is Haodong Tang from Intel China, and Jian Zhang and I work at Intel SG Group, and Fred Zhang work at Intel DCG Group. Today we are talking about Ceph RDMA and NVMe-oF. We will introduce how we accelerate Ceph with RDMA and how NVMe-oF influence the Ceph 4K read-write performance. So let's get started. So agenda. This talk will include two halves. The first half will introduce Ceph as a RDMA and Ceph networking component and how we achieve 70% performance benefit with RDMA. And the second half we will introduce how NVMe-oF influence Ceph 4K read-write performance. But at the beginning, we are introduce what is Ceph and why we need Ceph. Ceph actually is a distributed storage system. So at the first part, we will introduce what is Ceph. At the end is a summary and what we are continuing to do with RDMA, with Ceph, and the NVMe-oF. So the background and motivation. Ceph is one of the most popular distributed storage system in big data and cloud ecosystem. Ceph support all different kinds of interface, such as object interface, block interface, and file system interface. The RGW is a web service gateway for object storage that support object interface. The RBD is a reliable, fully distributed block device that support block interface, and the CephFS is for POSIX semantics. So all the upper layer interface are all based on the object storage. That in Ceph it can be a file store or boot store. It is an object storage system. Ceph is open source. Moreover, Ceph is also the most popular block storage service driver in OpenStack use case. Ceph is a benefit from Ceph's scalability and reliability. So these two pictures can be found in last year's Boston OpenStack Summit. That point out the CPU is uneven distributed across the Linux core. You can see from the left chart, the CPU tend to be the bottleneck in 4K read workload. But some of the core, the CPU utilization is lower than 80%. But some of core tend to be is close to 100%. For 4K read write, it is the same situation. We use perf and get the flame graph. As you can see from the right picture, we saw the async messenger consumes about 22 to 24% CPU of all the CPU used by Ceph. Async messenger is the default networking library in Ceph. We also benchmark the 4K read-write workload. The async messenger consume about 50% CPU of all the CPU used by Ceph. So in this case, the networking component in Ceph tend to be the bottleneck. After all, async message is welcome, but we have to rethink what we can do to reduce the CPU utilization and leverage the spare CPU to get higher performance in Ceph. So the motivation. After days of investigation, we noticed RDMA. RDMA is a direct access from memory of one computer from that of another without involving the operating system. RDMA support zero-copy networking. It can be also called kernel bypass. So since RDMA support zero-copy and kernel bypass, so it naturally eliminates CPU, memory, and context switch. So it also has the potential to reduce the message transport time. As for Ceph, Ceph is a distributed storage system, so the message must be transported between client node and the storage node, or between a different storage nodes. So, what's the benefit we can expect before our test is RDMA will bring better resource allocation and lower latency for Ceph. A better resource allocation means we can make use of the additional CPU spared by RDMA in Ceph to get higher performance. And also we have the potential to get lower latency generated by Ceph networking component. So RDMA and Ceph networking component. With deeper investigation, we found the RDMA has existed in a Ceph networking component. There is two RDMA implementation. The first one is SL Messenger. SL Messenger is based on Accelio project. Accelio is a networking library that supports different kinds of RDMA protocol. So SL Messenger support different kinds of RDMA protocol that Accelio project support. But from the benchmark result from Ceph community, the SL Messenger has some scalability issue. SL Messenger, the project has merged into Ceph Master 3 years ago, but no support for now. The other RDMA implementation in Ceph is async messenger with RDMA. Async messenger is a default networking component in Ceph. Async messenger is capable with different kinds of network protocol like RDMA, like DPDK or POSIX. Current RDMA implementation in Ceph support InfiniBand. So if customer want to use RDMA in Ceph, they must have InfiniBand hardware like NIC switch or other hardware, InfiniBand hardware. The right picture is the architecture of Ceph. The upper layer is a dispatcher. It can be Ceph different kinds of components, such like OSD, monitor, or other component. The middle layer is a networking library. Here is the async messenger. Async messenger is event-driven. All the messenger is handled by the work pool. The bottom layer is hardware. The network hardware, storage hardware, or other hardware. So we are thinking about if we can integrate around Ceph with RDMA over Ethernet. So it is great chance for us to integrate iWARP, Intel iWARP protocol into Ceph and leverage Intel NIC to accelerate Ceph. RDMA over Ethernet is one of the most convenient and practical way for data center that running Ceph over TCP/IP. With some investigation, we found if we want to integrate iWARP into Ceph, we need the RDMA CM library. So it is the more detailed implementation. Current implementation in Ceph, we listed the four main RDMA components. The first is connection management. Current current RDMA implementation in Ceph use self-implemented TCP/IP-based RDMA connection management. They didn't use RDMA CM library. The RDMA verb async messenger with RDMA use RDMA send and RDMA receive. They didn't use RDMA read or RDMA write. The queue pair. Current RDMA implementation itself support queue pair that is associated with shared receive queue, SRQ. Considering the CPU utilization, all the queue pair shared one complete queue. So since iWARP need RDMA CM library, so we introduce RDMA CM library to Ceph to provide RDMA connection management. We also support queue pair that is not associated with SRQ. One queue pair here corresponds to one RDMA connection. All the queue pair here is allocated from the centralized memory pool. So here is a benchmark methodology. We first benchmark on a small scale, one client node and one OSD node. OSD here is the name of Ceph storage service process. The client node we have 10 FL processes running on client node, and we have 4 OSD processes running on OSD node, and 1 monitor process running on OSD node. The FL sends the request to RBD volume, and RBD volume handled the message and sent the message to the remote OSD process through the RDMA networking component. So all the server here have the same configuration. The CPU we have the 122 Linux core placed on 56 physical core and 122 gigabyte. The NIC we use Intel S722 with RDMA warp as a RDMA NIC. We have 4 NVMe and Optane as a DB drive. The operating system is a CentOS S, and the FL version is 2.17. So the only variable here is different networking protocol, TCP/IP or RDMA. We change the protocol here. So here is the benchmark result. The good news is Ceph with iWARP delivers higher 4K read-write performance than it with TCP/IP. But the bad news is Ceph with iWARP generate higher CPU utilization. It makes sense at the first sight because RDMA is a kernel bypass and 0 copy, so it generates less CPU in the system level. But it doesn't make sense that Ceph with iWARP generate higher CPU utilization in the user level. We will try to answer this question in the following slides. The left chart we can see with the queue depth, FIO queue depth increasing, the 4K read-write performance of Ceph with iWARP keeps higher or equal to the performance of Ceph with TCP/IP. And the right chart, we see that Ceph with iWARP consume more user-level CPU, and Ceph with TCP/IP consume more system-level CPU. So we scale our testing cluster to larger scale, 2 client node and OS node. We want to verify the RDMA protocol scale-out ability. The RDMA NIC here is also the S722 Intel RDMA NIC with iWARP support. So here is the benchmark result. Ceph with iWARP delivered up to 27% 4K random-write performance benefit than it with the TCP/IP. The conclusion is the same as we saw in previous small scale. We also compare the 4K random-write ops per 1 CPU percent. We saw that Ceph with iWARP is more CPU efficient. The right chart, the higher is better. So we can see from the left chart, the RDMA benefit is also changing with the FRO QDEF increasing. We may need different tuning for different FRO QDEFs. So we continue to scale out the OSD node from 2 OSD node to 3 OSD node. We compare the performance with one OSD node, with one more OSD node, the Ceph with RDMA, the performance increased by 48%. And the Ceph with TCP/IP increased by 50%. So both of Ceph with RDMA or Ceph with TCP scale well in this test. And for the 4K random-write performance, Ceph with RDMA shows perform better than Ceph with TCP/IP. When QDEP is 16, the Ceph with RDMA shows a 12% higher 4K random-write performance than it with TCP/IP. So here we are trying to answer the question, why Ceph with iWARP generate higher user-level CPU than it with TCP/IP. Here is the perfect result. There may be 2 reasons. The first one is there is 2 polling threads in Ceph RDMA implementation. The first one is Ceph EPO-based async driver thread. That is for interact with different kinds of Ceph component, OSD, monitor, or others. The other polling thread is for RDMA complete queue. So there is 2 polling threads here. It generates higher user-level CPU. The other reason is maybe actually it is not really zero copy here in current Ceph RDMA implementation. Because there is 1 copy from RDMA receive buffer to Ceph async driver buffer. Actually, we also have a project named HDCS. It is a distributed cache storage. We also implemented the RDMA networking library for HDCS. It shows HDCS with RDMA can bring 10 times 4K random read performance benefits than HDCS with TCP/IP. So the RDMA is awesome, but the performance depends on how you use it. So the next part is the RDMA and Ceph mail fabric. NVMe is a new specification optimized for NAND flash and next generation solid-state storage technology. NVMe supports different kinds of fabric, RDMA, FC, or TCP/IP. I suppose everyone here knows the mail fabric, so I don't want to introduce the detail. Mail fabric benefit. The first one is NVMe disaggregation. We can disaggregate the NVMe, and the second benefit we can get on par performance with local NVMe. The other benefit is NVMe-oF will bring more flexible provision. So here is a benchmark methodology. We have two setups. The baseline setup uses local NVMe, and the comparison setup attach remote NVMe as a OSD node drive. If without NVMe-oF, there is two kinds of node in the benchmark, the client node and the OSD node. If with NVMe-oF, there will be three kinds of nodes: the client node, the OSD node, and the storage node. The NVMe is located at the storage node and leverage NVMe-oF to map the NV drive to remote OSD node as an OSD drive. We also set the NVMe-oF CPU offload on the target node. We also have 10 FL processes running on each of the client nodes. So totally, we have 30 FL processes. All these 8 servers are Broadwell 88 Linux core and 128 GB memory. We use Manilus Connect S4 NIC as the RDMA NIC. So before the benchmark, we had some expectation and question. So expectation, because we expect we will get on par 4K run-write performance compared with no NVMe-oF, just to attach the local NVMe. We expect on par CPU utilization on NVMe-oF host node. That means NVMe-oF didn't add extra CPU overhead on the Ceph OSD node. We also have some question, how many CPU will be used on NVMe target node? We don't know, so we have to benchmark. The other question is, how is the behavior of the tail latency with NVMe-oF? The other question is, does NVMe-oF influence the scale-out ability of Ceph? Because Ceph scale out well, but with NVMe-oF, we don't know how the scalability performs. So here is the benchmark result. Actually, we get on par 4K run-write performance compared with Ceph with the local NVMe, like the left chart. Also running Ceph with NVMe-oF brings 1%, lower than 1% CPU overhead on target node. We can see the CPU idle on target node is closing to 100%. So the CPU utilization on target node is small. So the CPU is not bottleneck on the host node. That means NVMe-oF didn't add extra CPU overhead on Ceph OSD node. So here is the Ceph tail latency, 99% latency. When Q depth is higher than 60, Ceph with NVMe-oF shows higher tail latency, 99% latency from FIO. When Q depth is lower than 60, Ceph with NVMe-oF have on par tail latency with with local NVMe. So here we may have some tuning here. We can tune the complete Q depth or or the polling time here. So here we verify the scalability with the ML-Fabric. We can see running Ceph with the ML-Fabric didn't limit the Ceph OSD node scaling out. From 2 OSD node to 3 OSD node with one more OSD node, the 4K rand write, the 4K rand read performance increased by 47%. That is closing to 1.5 the ideal value. So the Ceph with the ML-Fabric scale well with the ML-Fabric. So as the last is the summary. RDMA is critical for future Ceph All Flash Array solution. Ceph with RDMA messenger provide up to 70% performance benefit than it with TCP/IP. Ceph with RDMA messenger shows great scale-out ability. That also shows Ceph with RDMA have better CPU efficient than it with TCP/IP. RDMA as a network as NVMe fabric, RDMA perform well in Ceph over fabric solution. Running Ceph on ML-Fabric doesn't degrade the Ceph 4K rand read, 4K rand write performance. Ceph with ML-Fabric didn't brings more. Ceph with OpenFabrics bring more flexible provision in Ceph, and will bring lower TCO. So next step, we are continuing to optimize Ceph with ML-Fabric based on our previous analysis, such as two polling thread issue and the zero copy issue. We will leverage ML-Fabric with a high density storage, such like Intel White River Glacier. We want to get lower TCO in Ceph or flash array solution. So thank you. Happy to answer a question.
I noticed in the specs you picked MLX4, so you're not using like MLX5 with like EDR or something like that. So you're going to try to get better performance out of your RDMA connections by upgrading your network.
So you mean this picture?
On one of the sheets you mentioned you were using MLX4.
We use the Intel S722 as the RDMA NIC. We didn't use.
Okay, because you had that on one of your slides.
When we test Ceph with ML-Fabric, we use Manalox Connect S4 as the RDMA NIC. Yes, but for Ceph with RDMA, we implement the RDMA networking library that is for Intel iWARP protocol. But I suppose it can be also run on Manalox Connect S4 NIC, I think. So thank you.